Welcome back, colleagues. Before we continue with our memo discussion, there are several questions that I got, so let us get those 3 questions out of the way first. The first question was on 4.2.1. In question 4.2 there, colleagues, the learner was actually asked to write down the type of reaction. And already there, the learner was given whether it must be addition, substitution, or elimination. Now there's a question there when the learner in 4.2.1, instead of the learner saying elimination as expected there as seen in our memo, the learner says dehydrogenation. In actual fact, that elimination reaction there, it is dehydrogenation. So let us give that learner that mark. So the elimination reaction is actually the dehydrogenation reaction. So let us give the learner the mark, but let us ensure that when we discuss the memo, we tell them they must stick to the instructions so that they get the marks there. So they must choose between the ones that are given, not give their own. But because it is a correct elimination reaction, then let us give the learner the mark. Then the second question was in 4.3.2 there. In 4.3.2, in the last 2 bullets, it was said if only the product is given 2 out of 4, or if only the organic reactant is given, it's 1 out of 4. So the question is, do we apply marking rule 6.3.4 or do we just mark as it is? Because in the notes, it is not mentioned that it is marking rule 6.3.4. Therefore, even if the learner gives the product without the arrow at the left on the left-hand side, or give the reactant without the arrow on its right towards its right, let us give those marks as mentioned there. For example, in the last bullet, it is said if only the organic reactant is given. So we have 2 reactants there, but the learner just gives this organic reactant. The learner will still get 1 mark, even if the arrow there it's not given. And then the last question is on question 5.4. In question 5.4 there, the question was if the learner calculates the number of moles incorrectly, does the learner get 5 marks or 3 marks there? Now, colleagues, let us check the option there. The option says, the marking criteria says the final answer is 0.34. In other words, if the answer is not 0.34, that mark the learner already loses. The learner, if there's a mistake somewhere in the calculation, it means the learner may not get full marks. And then, if, for example, the learner in the calculation of the number of moles of the acid, the learner use incorrect values, then the learner will get incorrect this mark for substitution, the learner will lose. But if the learner says the number of moles of acid is equal to the number of moles of carbon dioxide, then the learner will get this mark. So the learner will get a maximum of 3 out of 5, meaning 1 mark for the formula, the substitution is incorrect, but saying the number of moles of carbon dioxide are equal to those of sulfuric acid, it's a mark, which is the second mark. Using the correct formula there to calculate the number of moles, and then using the molar volume and those incorrect number of moles transferred correctly to this formula there, for these 2, the learner will get the mark. So the learner will get a maximum of 3 out of 5. I hope that is clear, colleagues. Now, let us go back to our question. We are in question 7 there. Now, in our question 7, colleagues, we were given questions. Let us quickly go to question 7 because now we're busy with other questions. In question 7 then, the question says, many people use milk of magnesia, which is magnesium hydroxide, to relieve an upset stomach. The pH of the hydrochloric acid in a certain person's stomach is 1. Is hydrochloric acid a monoprotic or a diprotic acid? Now, if you quickly go to question 7 in our memorandum, the correct answer there, it is monoprotic. So the learner does not have to say acid because the word acid is already in the question. So if the learner just says monoprotic, the learner will get the 1 mark there. The second question there, 7.1.2. Calculate the concentration of hydrochloric acid in the person's stomach for 3 marks. Now the learner uses pH is equal to minus the log of concentration of H plus or minus the log of concentration of H3O plus, it's 1 mark. And then substituting 1 for the pH, it's 1 mark. And then calculating the concentration of H plus or of H3O plus as 0.1 mole per cubic decimeters there, it's 1 mark. So the learner will get 3 marks there. And then 7.1.3, how will the pH in the stomach be affected after taking a dose of magnesium hydroxide? Write only increases, decreases, or remains the same. Now the answer for 7.1.3 will definitely be increases. And then 7.1.4, write down the balanced equation for the reaction that takes place between the acid in the stomach and magnesium hydroxide. If the reactant is HCl and MgOH2, correct formula of magnesium hydroxide, correct formula of HCl, 1 mark for the reactants. And then if the product is MgCl2 and H2O, it is the 2nd mark. And then the 2 next to H2O and the 2 next to HCl, it is the 3rd mark, which is the balancing mark. And then you ignore the double arrows, and then marking rule 6.3.10 there applies, meaning for you to be able to mark the reactants, there must be the arrow, and for you to be able to mark the products, there must be an arrow there. And then 7.2, calcium sulfate is slightly soluble in water. Learners decide to test dam water from a local municipality for calcium sulfate. They treat a 0.5 cubic decimeter sample of dam water with excess sodium carbonate solution to precipitate the calcium ions present according to the following balanced equation, where calcium sulfate reacts with sodium carbonate to form sodium sulfate and precipitate the calcium carbonate. And then the calcium carbonate precipitate is then reacted with 30 cubic centimeters of a 0.1 mole per cubic decimeter HCl solution. The HCl is in excess. The balance equation for the reaction is calcium carbonate reacts with HCl to form calcium chloride, carbon dioxide, and water. So since HCl is in excess, not all of it will react with calcium carbonate. Then the one that is in excess is neutralized by adding 15.8 cubic centimeters of a 0.1 mole per cubic decimeter sodium hydroxide solution. And the balance equation for the reaction is HCl plus sodium hydroxide forms NaCl and water. And the question there says, calculate the mass of calcium sulfate that was present in the sample of dam water. Assume that calcium sulfate is the only source of calcium ions in the sample, and the total mass there is 9. Now, firstly, the learner must be given a mark for any of the formulae. If you give the mark on C is equal to N over V, you will not give the mark on N is equal to mass over molar mass. So any of these two formulae, the learner will get 1 mark. And then for substituting 0,1 and 30 times 10 to the power minus 3, this 0, the 0,1 and a 0,03 there, the learner will get 1 mark. And then for substituting a 0,1 and 15,8 times 10 to the power minus 3 there, the learner will get a mark there. And then the ratio mark there, when HCl reacted equals sodium hydroxide there, HCl number of moles equals the ones of sodium hydroxide, is 1 mark. And then another mark, number of moles of HCl initial minus the number of moles of HCl reacted there. This subtraction there of NHCl reacted minus, NHCl initial minus NHCl reacted there. And then the ratio there of calcium carbonate and HCl, this ratio there, the learner will get a mark, the correct ratio. And then the ratio of calcium sulfate and calcium carbonate, this ratio of calcium sulfate and calcium carbonate is a mark. And then the 8th mark there, it will be of substituting the molar mass of calcium sulfate in N is equal to mass over molar mass, and then the final answer there must definitely be 0,09656 grams. Now let us have a look. For the first mark, the learner can get it on N is equal to CV for calculating the number of moles of sodium hydroxide. That neutralizes the excess HCl. The number of moles there will be CV, 1 mark for the formula. And then for substitution of 0,1 of the concentration and 15,8 times 10 to the power minus 3 of the volume there, it's 1 mark. And then there's no mark for the number of moles of sodium hydroxide there. And then for using the mole ratio, the moles of NHCl that are in excess will be equal to the number of moles of sodium hydroxide. So the number of moles there will be equal to the ones of sodium hydroxide there. It is the 1 mark for the mole ratio there. And then now that the learner has the number of moles, then the learner can calculate the initial moles that are there, which is N is equal to CV, because we have already given the mark for the formula there. You don't need to give it here. And then for substituting the 0,1 that was given and the 30 times 10 to the power minus 3, which is 0,03 of the volume there, it's 1 mark. For both of the substitutions, it's 1 mark, meaning if any of them is incorrect, no mark there. And then for subtracting it is initial moles of HCl minus the moles of HCl that are in excess, then the learner will get the number of moles of HCl that reacted there. So for subtraction of the number of moles, initial number of moles of HCl minus whatever the moles that the learner got of HCl in excess, it's 1 mark. And then for using the mole ratio there, meaning 2 moles of HCl reacted with formed 1 mole of calcium carbonate there, meaning the moles of HCl are half those of calcium carbonate. Therefore, the number of moles of calcium carbonate will be half of those of HCl there. For that calculation, the learner will get 1 mark. And then going back again to the balanced equation, the number of moles of calcium sulfate equals exactly to the number of moles of calcium carbonate, 1 mark. And then for calculating the mass of calcium sulfate, substituting the 136 there of the molar mass in mass in N is equal to mass over molar mass there, the learner will get the 8th mark, and then the final answer there must be 0.09656 grams. Then the learner, if the learner rounds off here, the learner might actually get 0.10 grams, which is 0.1. If the learner says the final answer there, it's 0.1. Actually, the learner has rounded off correctly, so the learner will get the full marks there. So those will be the 9 marks of question 7 there. And then let us move on to question 8. In other words, colleagues, when you have a question like this, the arrows do not actually mean positive marking, because actually positive marking applies from one question to another. This is the same question. It is within the same question. So we just check the positive transference. But the final answer must definitely be the one that is given there in the memorandum. But for the correct transferences and for the correct mole ratios, the learner can get the marks there. So it is important to mark according to the marking criteria that is given there. It will be the one that will guide you where to give marks, and you work with the learner's mistake, but the final answer must definitely be the one that is given there in the marking criteria. Now let us move to question 8. In question 8 there, a magnesium plate is placed in a copper 2 sulfate solution as shown below. After a while, it is observed that the magnesium becomes eroded and another metal, represented by metal A in the sketch below, is formed at the bottom of the beaker. Then write down there, in 8.1.1, you write down the name of metal A. And colleagues, bear in mind, it is said name in capital letters. Therefore, the answer that is expected there, it is copper as the name, not Cu. And then 8.1.2, write down the balance equation, omitting spectator ions for the net reaction that takes place. So the net reaction there, it is Mg plus Cu2 plus for the reactants, and then for the product it is Mg2 plus Cu there, and then for balancing then it is 1 mark. In other words, nothing it's written there on the left hand side of each of them, or if the learner writes the 2, it will be the 2s in all of them, so it must be the correct number there for the balancing. And then ignore the double arrows, and then ignore the phases there. Even if the phases are not there, the learner will get full marks. And then marking rule 6.3.10, where the mark for the reactants can only be given if the arrow, and for those of the products also can be given if there is an arrow there. And then question 8.2, the electrochemical cell represented below functions at standard conditions. Is the above cell a galvanic or an electrolytic cell? Now the only answer expected there, it is a galvanic cell. Because the cell is already in the question, the learner can just say galvanic. And then 8.2.2, write down the name of the component represented as X in the above diagram. And the only answer there, it is the salt bridge. Colleagues, it is the salt bridge, and that's the only answer. Not salt anything, but salt bridge for 1 mark. And then 8.2.3, define the term reducing agent in terms of electron transfer for 2 marks. So in 8.2.3 there, the learner can say a reducing agent is a substance that loses electrons. It's 2 or 0. substance that loses electrons. The learner, because the question says in terms of electron transfer, then it is important to say loses electrons. And then 8.2.4 there. In which direction do electrons flow in this cell? Write down to the left or to the right. And then refer to the relative strengths of reducing agents to explain the answer. Now, 8.2.4 there. The answer is to the left. Then for you to be able to mark the answer, the reason, the learner must have written to the left. If the learner writes to the right, it's 0. And then if the learner does not write to the left and only write reasons, it's 0. The reasons there is magnesium is a stronger reducing agent for 1 mark than H2O2 for the 2nd mark. Therefore, magnesium will be oxidized for the 4th mark, or magnesium will lose electrons. In other words, the learner must say magnesium is a stronger reducing agent, not it is a stronger reducing agent, because the learner is talking about 2 reducing agents, which are magnesium and hydrogen peroxide. So the learner must say magnesium is a stronger reducing agent for 1 mark than hydrogen peroxide for the 2nd mark, and then the last mark is for magnesium is oxidized or magnesium loses electrons, not it is oxidized. And then 8.2.5, write down the cell notation for this cell for 4 marks. Now, the marking criteria for the cell notation, there are 4 bullets there for each mark. For the 1st mark, magnesium half cell is written as the anode to the left of the double line. And then the oxygen hydrogen peroxide half cell is written as the cathode to the right of the double line. And then the 3rd mark is for the salt bridge, which is the double line. And then the 4th mark there is for the correct sequence of the formula and commas and the lines of the phase separation correctly used as shown in the cell notation below. And then note, colleagues, you may ignore the phases. So, for the 1st mark there is magnesium and magnesium ions there to the left of the salt bridge, 1 mark. And then the half reaction of the hydrogen peroxide there to the right of the salt bridge, the 2nd mark. The 3rd mark is for the salt bridge, and then the 4th mark is for everything in the correct sequence with the correct lines for the phases there. The correct lines, in other words, here the lines is between the oxygen gas and the hydrogen ions aqueous solution, because it is the lines for the phase separations, and there is a comma there. There is platinum there at the end for the correct sequence here, and the correct commas and lines of phase separations there. It is the 4th mark. And then the learner may choose not to include the phases. If everything is correct, the learner will still get 4 marks there. And then 8.2.6, calculate the initial reading on the voltmeter there for 4 marks. The 1st mark will always go to the formula there. Please include their marks that are missing, their ticks that are missing there. For EMF of the cell equals E cathode minus E anode, there's 1 mark for the formula, or any of the correct formulae that are given in the in the question paper there for the learner. And then for the substitution of 0.8 there for E cathode, it's 1 mark. There's a tick on 0.68. And then the second mark, it's when the learner minus the negative 2.36 there. And then the fourth mark is for 3.04 volts. Colleagues, please, the unit must be there. If the unit is not there, the fourth mark is gone. Or the learner can use option 2, where the learner writes the magnesium half cell as oxidation. So magnesium forming magnesium ions plus 2 electrons, and writes the oxygen hydrogen peroxide half reaction as reduction correctly. For those two correctly written, it's 1 mark. And then since the magnesium already is written as oxidation, then its EMF must be there shown as positive, 1 mark. And then the EMF of the E cell for the hydrogen peroxide there is 0.68, 1 mark. And then the last mark, colleagues, please include it. It's on the EMF equals 3.04 volts there, 1 mark. The unit must be there. And then on the notes there, you accept any other correct formula from the data sheet, as I've said, and then any other formula using unconventional abbreviations. For example, E cell is equal to EOA minus ERA, or EOX minus ERED, or ERED minus EOX. The learner will lose the mark for the formula. If everything else is correct, the learner will get a maximum of 3 out of 4 marks there. Colleagues, please rectify. It's 3 out of 4, not 4 out of 5 there. And that was question 8. Now let us quickly go to question 9. The diagram below represents an electrochemical cell used to decompose a concentrated copper 2 chloride solution using inactive electrodes. Write down in 9.1 the energy conversion that takes place in this cell. Now the energy conversion there that is expected, it is electrical energy to chemical energy. Because energy is already mentioned in the question, the learner can just say electrical to chemical. There is 1 mark for the correct way of writing this. So it cannot be chemical to electrical, but it is electrical to chemical energy for 1 mark. And then 9.2 there. At which electrode, A or B, does reduction take place? Now the correct answer there for 9.2, it is at A for 1 mark. And then write down the name of the gas formed while the cell is functioning. The question is name in capital letters. So for 9.3.1, the learner must say chlorine gas. But because gas is already part of the question, the learner can just say chlorine, not Cl2, colleagues, because the name is needed there. So it must be chlorine, not Cl2, not Cl, nothing. It must be chlorine. And then question 9.3.2, write down the half reaction that takes place at electrode A, and that half reaction is Cu2 plus 2 electrons forming Cu. And those are 2 marks at the end. In other words, Cu2 plus and 2 electrons must be on the left-hand side of the arrow, and then Cu must be our product for the learner to get 2 marks. If the learner, for example, omits these 2 plus here as the reactant, then the learner will lose the mark. And then if the learner uses double arrows there with the Cu2 plus and 2 electrons on the left and Cu on the right hand side, you just penalize 1 mark for using the double arrow. And then If the learner uses the double arrow, but the CU is on the left-hand side, and then CU2 plus and 2 electrons are on the right-hand side, then it's 0. If the learner uses the CU on the left-hand side and CU2 plus 2 electrons on the left-hand side, but the arrow pointing that Cu is the product and Cu2 plus and 2 electrons are the reactants, then the learner will get 2 full marks. But if the reactant is copper and the products are copper ions and 2 electrons, then it will be 0 out of 2. 9.3.3, write down the name or formula of the oxidizing agent and give a reason for the answer. Then the name or the formula of the oxidizing agent there is copper 2 plus or copper 2 ions. So if the learner uses the formula, then the learner can just say Cu2 plus there. But if the learner uses the name, then the stock notation must definitely be present there. So it must be copper 2 ions. If the learner just says copper ions, then the learner will lose the mark there. And then the reason why the learner says copper 2 ions must be copper 2 ions are reduced, or copper 2 ions gain electrons. That is the reason there. And then 9.3.4, write down the name of a substance that can be used as electrodes in this cell. The name of a substance that can be used as electrodes. So the name there can be carbon or graphite or platinum, but the names, colleagues, not the formulae. And then 9.4, how does the concentration of the copper 2 chloride solution change when the reaction proceeds? Write down increases, decreases, or no change, and then give a reason for the answer. The answer there is decreases. And there's negative marking there, meaning the learner must definitely mention that the concentration of copper 2 chloride solution there decreases. And then the reason there is chloride ion is oxidized to chlorine gas, and copper 2 ions are reduced to copper. So it is important not just to say it is oxidized. The learner must say Cl minus or chloride ions are oxidized. And then for the second mark, the learner must say Cu2 plus is reduced or copper ions are reduced. But if the learner writes this in this way, without saying oxidized or reduced, but using the words changes, then the learner must mention chlorides change to Cl2 and copper ions change to copper. But if the learner uses oxidized, then to chlorine and to copper need not be mentioned. Now that is the last part of question 9. And then colleagues, let us move to question 10, which is the last question in the chemistry paper in this trial exam. Different processes used in the preparation of fertilizer C are represented in the flow diagram below. And the flow diagram there is given. Use the above information and write down the name of the industrial preparation of nitrogen there for 1 mark. So the name of the industrial preparation of nitrogen there, it is fractional distillation. And colleagues, please ensure the learners write fractional distillation, not frictional. It is fractional distillation of liquid air, but the of liquid air can be ignored. If the fractional distillation is there, it's 1 mark. And then 10.2, write down the name of process X there. The name of process X there is harbor process, but because the word process is there, the learner can just say harbor. And then for 10.3, write down the name of reaction Y. Reaction Y there, it is the catalytic oxidation of ammonia. But because it is shown that the reactant in reaction Y is ammonia, so the words of ammonia can be ignored and the learner can just say catalytic oxidation. And then 10.4 there, write down the name or the formula of compound A. So the name or the formula of compound A is O2 if it is the formula, or oxygen if it is the name. The phases may be ignored, so the learner may not include the G or the gas because already it is shown it is a gas. So the learner can just say O2 or oxygen. And colleagues, please, it is not O, because in nature oxygen exists as O2, not as O. And then 10.5, write down the balance equation for the preparation of compound B from NO2. The balance equation there for the reactants, there must be NO2 plus O2 plus H2O to get a 1 mark for the reactants, and then there must be HNO3 on the right hand side to get the mark for the products. And then for balancing with the 4 on NO2, the 2 on H2O, and the 4 on HNO3, the learner will get the 3rd mark. And then you may ignore the double arrows there. And then marking rule 6.3.10 applies there, where for you to be able to mark the reactants on the products, there must be the arrow there. And then the last question of the paper, which is 10.6, write down the balance equation for the preparation of fertilizer C. Preparation of fertilizer C, NH3 plus HNO3, 1 mark for the reactants, forming NH4NO3, 1 mark for the products, and then not writing any number for balancing or writing the correct multiples there, it is the 3rd mark for the balancing there. And then you may ignore if the learner writes a double arrow there, and then marking rule 6.3.10 applies there, where the reactants and the products, for you to be able to mark them, there must be an arrow there. Now that brings us to the last part of our memo discussion. Colleagues, I hope you were able to see how you are supposed to mark and what is it that you are supposed to do and how you are supposed to give marks. And please ensure that you put the tick exactly where the correct answer is, so that the learner knows where the mark, where he or she is correct, and put the cross where he or she is incorrect, so that they know what to rectify at the end of the year, and penalize accordingly where it is necessary. Where there is negative marking, ensure that you penalize accordingly. And please emphasize to them that the marks in most cases are on the reason more than on the answer. And for you to be able to mark the reason, the answer must be there first and must be correct. So the learners, before they go to the reasons, they must ensure that they answer the question first. Thank you very much, colleagues, for everything, and good luck with everything. I hope your learners will pass the trial exam so that it boosts their morale for the final exam. Thank you so much. Goodbye.